So we'll continue this number 3, the algebraic part. Sine 2x minus sine x. See if we can find the, it's equal to 0. If we want to try to do this algebraically, at first you're like, well, do I go use one of those double angle formulas? I could. Let's look at them and see what we think. The double angle formulas are on page 387. And for sine 2x, we get 2 sine x cosine x. Well, you know what? That actually might be okay. I can think of another way to do this algebraically, but let's use the double angle formula since we're in that section. I'm thinking that's probably what they're thinking we're going to do. This right here, 2 sine x cosine x, if you look at the formula, this is how you could rewrite this. So if you did that, you've got it set equal to 0. Can't we, if we can factor this, it says set equal to 0, we could then set each factor equal to 0, right? So I could take a sine x out of both of those terms. It's the greatest common factor. And I could say I have 2 cosine x left out of the first term. I'm going to copy my subtraction sign on it. If I take sine x out of sine x, it would just be 1, right? So once I factor it, I'm back to thinking like stuff you did in Algebra 1, set each factor equal to 0 to solve it. So this one you can actually solve pretty easily if you make that substitution. So either sine x is equal to 0 or 2 cosine x minus 1 is equal to 0 because those are our two factors there. Now let's see, do they tell us to find all the solutions or just in the interval 0 to 2 pi? So we're not going to do the plus something in on it. So let's see, we know we've got a sine value equal to 0 here, and sine on the unit circle is which one, x or y? Y. So we're looking for y's of 0. That means they'd be here or here, right? And that point is 0, no, it's 1, 0. I don't know why that's so hard for me to figure out. And that's negative 1, 0. So it could either be, x could be 0. You could call it 2 pi if you wanted to. Or x is equal to pi, right? So those are two solutions. I can go ahead and circle them. They're solutions. But now I got to go deal with the other factor. So what am I going to do to this to actually figure out what it needs to do? When I see this, how do I go about solving it? Yeah, we're going to undo it. We want that trig function by itself, right? We want to get this by itself. So if I add 1 to both sides, I get, and then I could, well, let me go ahead and do 2 cosine x is equal to 1. And then I divide both sides by 2. I get cosine x is a half. Okay, sine of 30 is a half. So cosine of 60 would be a half, right? And 60 is 180 divided by 3. So 60 would be pi over 3, right? Except, it's positive. I didn't do any square rooting here, right? So I'm not going to consider both the positives and negatives because I didn't square root anything. So we just still need to look at all students take calculus. Cosine is positive in the first quadrant, so this is one of my answers. And it's positive in the fourth quadrant. How am I going to get that fourth quadrant answer? The x-axis would be 2 pi at that point. And you subtract pi over 3. We get a common denominator of 3 over 3. So it will be 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. Do any of y'all think it's easier to do that when you say it out loud? No.
It's just as hard. Maybe it's just me. I don't know.
No, I don't know. There's sometimes if I say it out loud, I don't know.
It's like, oh, I have to get it right now.
So there, we have 4 solutions just in that one trip around our unit circle. Okay, don't be afraid to play, first of all. I look at that 4x and I think, oh man, my first thought was just to go look up the formula and put it on both sides, and then do the formula twice on this one. That was my first thought. Well, we have a formula for sine 2x, But if it's 4x, I might have to think of it as sine 2 of 2x. And a lot of times that confuses people. What you can do here is, this is the technique, you might as well go ahead and play with it, because this is what we do in calculus almost every day, okay? Let's let u equal 2x. I could rewrite this as sine 2u, because u is 2x, right? I could do that, is equal to negative 2 sine 2x. Just because I can see that's like a double angle, isn't it? And I don't think, let's see, I don't see any formulas in here that allow me to go ahead and take that and do, something with it just straight outright. So I'm thinking that I'm going to have to apply the formulas on page 387 twice to that one thing. Oh, it went upside down on me, but not on y'all. Oh, it did. Okay. Whatever. All right, so I'm going to rewrite these. For sine 2u, I don't have any choices, which I'm happy for, because I don't like having too many choices. I don't know which one to pick. So sometimes no choices is a good thing. So sine 2u in the book is 2 sine u cosine u. Okay. Now let's put the 2x's back in. I'm going to unsubstitute, if you know what I mean here. Because now I can apply the formulas directly, right? It looks like it made it a lot worse, but at least I've got something I can do there. So in calculus, you do this a lot to do your thinking, just to kind of help you get through. Did I really write that down correctly? All right, now I'm going to go ahead. In a minute, I'm going to have to do some more substitution in there, but right now what I'm going to do is go ahead and work on the right-hand side a little bit too. Sine 2x would be, if I replace it all, now you look at the little blue box that has the formula in it, that's 2 sine x cosine x. Okay, so this is going to get messy, to say the least. That would be negative 4 sine x cosine x, but at least the two x's are gone off the right-hand side, correct? Whether we like it or not. Okay. Now, I got to work on the left-hand side. Every time I see sine 2x, remember that's going to be 2 sine x cosine x. So I'm making that substitution again. Let me underline in a different color what I just did. I took this out, and I put this in its place, just using the formula on page 387. Okay, now, I have to do the same with cosine 2x. I don't know what it is either. So cosine 2x, I'll do that substitution in blue. Now, I have choices here, and I'm not crazy about having choices. I'm not quite sure which one to pick here, because I get 3 to use. I have a cosine on both sides. Maybe I want to stick with sine. I'm going to stick with sine. Just because I notice I got a cosine x here, and I've got one on the other side, so maybe I can divide those out. And if I introduce another cosine, I might have more of a mess than I want. I don't know. So what I'm going to do, I'm going to use the one that is 1 minus 2 sine squared u, or 2 sine squared x in this case. Because I do know I'm going to have some things on both sides that I can divide out. Or, actually, dividing out is not a good idea. Does anybody know why it wouldn't be a good idea? Can I divide by 0?
No.
Is it possible that if I'm dividing these out, it's kind of like dividing by 0. If I factor it, you'll see what I mean. So let me show you, let me factor this instead. You've got to be careful about dividing things out of both sides, because it's like you took a factor out of both sides that might have been a solution, especially if it was equal to 0, it would have been a solution. Let me simplify all this mess first though. So over here I have 4 sine x cosine x times 1 minus 2 sine squared x. This looks so ugly. Now let me add, the right-hand side is negative, so let me add that to both sides. And on the right-hand side, since I moved it over to the left, that would be 0 now. Now I can factor and solve. You're thinking, yeah, I really want to, don't I? Not really, but yeah, I mean, it might work. We'll see. I think it should. This is difficult, isn't it? And it's just that other factor in there. Now, do you see that in both of these I have 4 sine x cosine x? So couldn't I pull that out? So I'm going to pull out, I'll just write it in green just because we can see that I underlined it in green. If I pull that out, what I have left out of both of those terms is 1 minus 2 sine squared x plus 1. If I divide it out of that second factor, I have to put a 1 down, right, because I divided it out. Okay. Let me write this down and go to a new slide. Learn more in here by going through these problems than I would if I sat and listened to somebody. Okay, inside, here's what we have. We have 4 sine x cosine x. This is a lovely problem. Isn't that 2 minus 2 sine squared x on the inside? If I combine that 1 and that 1. Okay, can I keep factoring here? Yeah, look inside of there. Let's split it into 2 problems so it doesn't get so nasty. You can break problems down to smaller parts and keep it from being such a nasty thing. Let's do that. All right, so first of all, let's just look at the solutions that I'm going to get from this. If I set 4 sine x cosine x equal to 0, because it is a factor, I do have 2 things multiplied by each other. I could actually put that all in parentheses if I wanted to. If that's equal to 0, I can divide both sides by 4 and just get, let me write in a different color, sine x cosine x is equal to 0 if I divide both sides by 4. That means sine x could be 0 or cosine x could be 0 also, right? On the whole unit, doesn't that mean anything on the unit circle that has an x of 0 or a y of 0 would be a solution? So isn't that all the different unit circle angles? Without like us stressing about it, every single angle on the unit circle has a 0, either in its x or y coordinate, and sine x covers the y coordinate, and cosine x covers the x coordinate. So we could just go, okay, let's see. They want it in one interval, so we don't have to worry about going on forever and ever. So we know it's going to be 0, pi halves, pi, and 3 pi over 2. Yeah, that would be a multiple. Yeah, they usually put the close parentheses on the 2 pi so that you don't count 2 pi. That's how they kind of do. It's just a random decision, but that's what they do. Okay, so now I got this other one to solve. 2 minus 2 sine squared x equals 0. I could divide a 2 out of every term, couldn't I? Let's do that. That's a quick way to get rid of it. 1 minus sine squared x equals 0. Let me just add sine squared to both sides. I could do that, right? If I don't want negatives. I could add sine squared x to each side, but I'm going to go over on this video. And I'd get 1 is sine squared x. And what am I going to do to solve that? I got a square on my trig term, so I need to square root both sides. And when I square root it, right? So what do I have to put on that 1? Good, plus or minus, because I square rooted in my solving. That's how you have to look at it. If the book doesn't write plus or minus, you just look at the positive one. But if you are solving and you have to take the square root, you have to consider both. That's the rule of thumb that's never stated that I finally figured out after looking at the answer key. So sine x is plus or minus 1. Okay, so we're looking on, isn't that just going to be on, no, what has a sine value of 1, a y value of 1?
Pi halves, right?
It would. So we've already got that one, right?
Oh, you're looking for more of them.
Well, at first I thought this was just going to be the unit circle. Actually, you're right. It is just pi halves, isn't it? Because it's the only one that has a 1 that's positive. For a minute, my brain went over and was thinking about 45 degrees, but that's tangent of a 45 degree, that's 1. So I was just going in the wrong direction. So we got pi halves twice, but there's our solutions right there.